Good afternoon. It's 3 o'clock now, and we'll start this webinar off. Thank you for joining us on this webinar. This is about the implementation of spill prevention control and countermeasures plans, or SPCC plans. These plans are mandated for most facilities that store more than 1,320 gallons of most types of oils. However, one uniqueness about SPCC plans is that they're not required to be submitted to the EPA to any other agency for review and approval, which means that the adequacy of a plan is mostly evaluated when there is a spill or if there is a related incident. This is also a federal regulation, meaning that the enforcement of the SPCC regulations rests with the US EPA regions, and the guidance for federal inspectors that are responsible for responding to spills and for evaluating if your facility is adequately covered by an SPCC plan is 921 pages long. And so when we had someone that was experienced in implementing these plans, namely Richard, he offered to share his experience with SPCC plans and spill response. We absolutely jumped at that opportunity to help us and to help all of you prepare better SPCC plans and to better implement the elements of this of the program. A couple of quick housekeeping items. We are recording this webinar, and we will have a link for sharing when we are done at the end of this. Amy Blythe from Trihydro is monitoring the chat, and we will take questions through the chat throughout the presentation with a Q&A session at the end, depending on how much time we have available. With that, I'm going to give all the time available to Richard. So, Richard, thank you. Please take it away.
Great. Thank you so much, Rajib. So we'll go through what we can here. The presentation I'm giving on the SPCC rule and how to implement it is for main items only. There's a lot that can be taught or talked about, certainly with the SPCC rule, but we'll go through some of the main components of the rule. So we're going to start off right away. I hope you can hear me okay. If there's any issues, I'm sure Rajib or Amy will let me know. Okay. So what we'll go through again are some major items, components of the rule. First off, some of the keystones, applicability, and then things like bulk storage containers, containment, pitfalls, oil field, some other items like that. So what is the rule, right? So the rule's been around for a long time. It was promulgated, became effective in 1974. And the authorization is from the Clean Water Act. So this rule applies to facilities that, by virtue of their location and what they're storing, could reasonably be expected to have a spill get to waters of the United States. Some of us joke that it's not authorized by the Clean Dirt Act. Everything is based on a threat to a waterway of the United States, or WOTUS. Under the rule, they call it navigable waters of the United States and adjoining shorelines, but that's also the same thing as WOTUS, which is, again, is waters of the United States. And as you're probably aware, that's been in flux with different Supreme Court decisions and some litigation. The rule is codified in 40 CFR 112. As Rajib was saying earlier, it is not delegable to any other state, federal, local, or tribal agencies. And the main reason we have this rule is to keep oil out of water of the United States. The plan, there must be a plan. It's got to be written and implemented, right? And the plan really should be a site-specific plan. You're going to see this over and over again from me and hear this. It really needs to deal with your site and your waterway and your surroundings and your operations and how you can prevent oil from getting to waters of the United States in your area. Some of the keystones, again, are secondary containment and then procedures to prevent oil spills. If you have an inspection and if there's violations or deficiencies, one of the key things we're going to look for is, do you have adequate secondary containment? Do you have containment at all? You must have measures to control it, right? Keep it from getting to waterways, and then be ready to go should you have a spill. So this is all about keeping oil spill out of waters of the United States and adjoining shorelines. That term, that phrase is in the rule as well. So if the spill gets to the waterway, a creek, pond, river that's defined as waters of the United States, then potentially enforcement can trace it all the way back up to whatever the adjoining shoreline is. So what do? You need to prepare a plan with good engineering practices. Um, Most plans are signed off or required to be signed off by a PE, professional engineer. We look at the PE as a third-party regulator, really, and the plan should have full approval of management, and this should follow the format of the rule in 112. You can use a cross-reference if you like, and we'll get to cross-references, I think, a little bit later as well. But full approval of management. There needs to be signature on a management approval page, and PE will need to sign off on it, and again, done with good engineering practices. As I mentioned a little while ago, right, this is a site-specific plan. We have plans that show up from companies that may have multiple terminals or facilities in an area, and they might want to write one general plan for the whole thing, for all of their facilities within that area. But there may be some commonality between administrative stuff in the plan between different facilities, but really they should be talking about each facility, the waterway that it's threatening, and how to prevent it from getting there, the procedures at that facility as well. It's fine to have some generic language mirroring the rule, but what we really don't want to see is just generic language only, and not dealing with the site-specific information in the facility. What we say is that the plan should mirror what's really going on in the field in your facility, and whatever is really going on in your facility ought to be mirrored in the plan, right, as far as how you write this. And talking to Rajib, he asked me, Richard, what's important? And I'm like, well, okay, so having a well-written plan, implementing that plan. When we show up to do an inspection and review the plan, one of the main goals, of course, reviewing the plan against the rule. But one of the big things is, can you implement the plan? Is the plan being used as a doorstop or is it just sitting gathering dust on your bookshelf? You understand that you have to have these for regulatory compliance, but it should really be able to be used. And you're supposed to train your employees on your oil handling employees on it as well. So it should really be implemented. You should have appropriate secondary containment. We'll talk about containment in depth a little bit. Tank integrity, also hugely important, and have adequate drainage control. So those are some of the big things that we really look for. And we'll note sometimes that a plan might be written well, and it doesn't really, when we show up at the facility, the plan looks good on paper, right? But it doesn't really have any reality as far as what's really going on at the facility, right? Those need to mirror each other. We're going to jump right into bulk storage containers. So again, some of the main things in the rule. This is in 112.8C, and so a couple of things right off the bat. It says that no container should be used for the storage of water unless its material and construction are compatible with what you're storing and the conditions of storage. And so the climate, for instance, what's in your area? Are you in a wet climate like I'm at? I'm, here on the West Coast teaching from west of the Cascades where it's very wet. Maybe you're in the Gulf Coast of Texas where I'm from originally, where it's also wet and rains a lot, right? Conditions of storage, is it salty air? Is it sea air? Are you going to have more corrosion? Maybe you're in a dry place where you don't get much rain. So again, the container really needs to be able to store, be compatible with materials stored, whether it's crude oil, diesel, gasoline, naphtha, whatever it is, construction of it, and pressure and temperature. And then secondary containment, and again, we'll talk about that. You've got to have secondary containment for the bulk storage containers, and you'll note that the rule is says bulk storage containers, which includes things that are not tanks, like drums and totes and things like that might meet the regulatory thresholds. It also says in 112.8c that diked areas should be sufficiently impervious to contain spilled oil, which is interesting, right? We do not have any quantitative rural language or guidance on what is impervious meaning. In 112.7c, which governs the whole rule as far as containment goes, it says you've got to be able to hold oil until it can be cleaned up. In our guidance, we say that should be really is up to 72 hours. So we'll get into that here a little bit more. Here's a great photo. This was taken in Dallas, and it shows, if we show up at a site and we see this, we're going to say those tanks are no longer appropriate for the conditions of storage and what's being stored, or the construction of those tanks. Those tanks, if you'll note, the vertical ones that are rusted are really, those are USTs. They're being used as ASTs. And so their construction and stresses are not meant for holding oil above ground, right? They're meant for below ground. Surface rust is one thing, but when we see large-scale pitting and corrosion, delamination of metal, we'll say, again, that's a violation or deficiency. It's no longer compatible with conditions of storage and what's being stored in it. I like this photo also because if you look at secondary containment, you'll find some interesting things. The white concrete wall there ends in the middle of a tank, right? So that's inadequate secondary containment. I'm also not sure with the footprint of all those tanks inside containment whether there's enough volume there anyway to meet the volume of the single largest tank, which is what the rule requires in a common area like that. They've got some housekeeping problems. The rule doesn't talk so much about housekeeping per se, but that could be a safety issue for you, right? If you have things like this metal ladder that's against the concrete, if that's leaning up against metal tanks and it just sits there or other metals, then you can induce corrosion cells and that becomes a problem as well. So that gets to routine inspections and integrity. So the rule says you've got to do routine inspections and tank integrity testing. And for tank integrity testing, the rule says the owner or operator must consult with the industry standards. We'll get to those in a minute to determine what kind of integrity testing is required for the specific type of tank that you have, what's the frequency of it, and certainly you've got to be doing visual and outside inspections as well, looking for deterioration, leaks that might cause a spill, well, it's already spilled inside diked areas, especially looking at the base of the tank and foundations and supports, because that's where so many of the stresses are going to be. And you might have water at the base of a tank too internally, which could cause corrosion or begin causing corrosion. So routine inspections, a lot of the standards that are used require monthly and annual inspections. So there's a lot of confusion surrounding these. So what standard should you use? Now, I'm not a PE, but we look at the standard and what the most appropriate standard is. So API, American Petroleum Institute, the most appropriate standard, that's the most appropriate standard for large field erected tanks. The Still Tank Institute, SP001, is most applicable for shop-built tanks, drums, totes, and some small field erected tanks. Now, we have our own PE, actually with EPA, that sits on one of the technical boards of STI for SP001, and that's helped us try to understand and be more flexible and realistic on how that standard would apply to these smaller containers. We see that smaller tanks are often completely overlooked. For instance, at a bulk storage terminal, refined products marketing terminal, right, distribution terminal, and the facility is certainly doing API 653 integrity testing for their larger tanks, 55,000, 80,000 barrel, 30,000 barrel, 100,000 barrel tanks. And then they forget, in the 10,000 additive tanks, that those also have to be looked at as far as tank integrity testing. And typically those are going to be shop built, and SP001 would apply to those. And when we come to do an inspection, we're going to ask for your inspection reports, right? We want to see that you've been doing monthly, annual inspections, visual walkarounds, and depending on the standard, are you doing the appropriate kind of inspections? And then we're going to look for records proving that up, right? And then a follow through. So if you have an API 653 out of service, a full on inspection internal, and the report comes back and says, here are the recommendations, you should do these things. We want to look for the recommendations to see if the facility has completed those. Again, API 653, what does it cover? Again, field-erected steel storage tanks built to the API 650 construction standard and its predecessor, which was API 12C. Again, specifically developed for vertical petroleum storage tanks with a maximum internal pressure of no more than 2.5 psi and a temperature not exceeding 200 degrees Fahrenheit per the scope. The tanks that are heated higher than that have other standards that apply to them. SP001, now that's again, Steel Tank Institute has this standard, applies to shop-built tanks and some small field-erected tanks and portable containers. And again, it has a chart and some lays out specific intervals of internal and external inspections of shop-built tanks. And so again, some of the smaller field-erected tanks, based on the size of the tank and the configuration, gives specific intervals for external inspections of portable containers. And again, most of the inspection interval is monthly and annual. And depending on the tank size and configuration, whether it has a release prevention barrier or secondary containment around it, it may only need visual for much of its life, which I think gives you a lot of flexibility. It's not quite as rigorous as API 653 might be, certainly for smaller tanks. And so here you see some examples of some of the shop-built tanks. There's a tank. The picture in the upper left-hand corner is a 20,000 gallon double-wall tank. So it has secondary containment, right? It's above ground. So it has a release prevention barrier underneath it, concrete. These other photos are smaller. The photo on the right top is a double wall tank as well. They even put some extra curbing around it, which is a nice thing to have. And then the drum, and of course the lower tank on the right, which is a single wall, but they've got a good metal secondary containment. But again, SP001 applies to those. Again, most of those are, as far as inspections, are monthly and annual. Who's responsible for doing this? For the longest time, we saw that companies were not, especially smaller companies and some other companies like some of the asphalt industry, were not doing these. And we're hoping that they're doing them now. But the owner operator is responsible for doing it. And that says that in the law and the regulation, not just the owner and not just the operator. We've had instances where we've done inspections and the operator, for instance, at a large airport in the U.S. owned by the city, and they have lessees and fixed-based operators, FBOs, working on their airport. And they refuse to let the operators fulfill some of the things they need to do to be compliant with the SPCC. So the owner, the city, got fined. The law and the regulation says owner operator. When we do inspections, the first entity we're going to look at is really the operator. Who's operating the tank? Who's maintaining it? Who's taking care of it, right? So these photos here, again, we're going to be looking at the whole tank, but certainly the base and the chime of the tank, welds, maybe bolted, riveted tanks as well. This particular tank where that pin is, and also on the right-hand photo shows delamination of the chime we noticed this corrosion, not just peeling paint, right, but large-scale pitting and corrosion. We pointed this out to the facility. They had not done any internal integrity inspections, and a month later it failed, and they lost 1 million gallons of asphalt cement or asphalt oil. So we don't hold the PE responsible. We hold the owner-operator responsible. Overfill protection, you've got some choices, but tanks have to have overfill protection, right? At least one of these four. You don't have to have all of them. You can have high liquid level alarms, a liquid level pump cutoff. If you're just loading directly into the tank, as long as from a truck, the truck driver's there and the gauger or the pumping station person is there, someone's at the tank, someone's at the truck loading it, that might be fine. It'd be great to have gauges on it. Sometimes for smaller tanks, you want to stick the tank. But you've got to know you have good inventory controls, and you've got to know how much you get in there so you don't overfill the tank. And then if you have liquid level sensing devices, those have to be tested frequently. We don't say how frequently, but you got to follow the manufacturer's recommendations. Typically, it's often monthly that we see that. So here we have a tank that did not have good overfill protection. And of course, we've had a problem with secondary containment as well. The fuel went right through the concrete. And if we drive up and see that, that's a violation. So they have different types of tanks there with different types of containment. But again, that's a problem. Now let's get to secondary containment. There's the word that starts out right away in 112.7c is appropriate secondary containment. So it's got to be appropriate to what you're holding. If we go to the Gulf Coast or the West Coast or East Coast and we see a tank of gasoline with a berm made out of crushed oyster shell, that's not appropriate, right? It's not appropriate to use kitty litter as secondary containment for a tanker truck at a loading rack. You're not going to really be able to hold that, right? We've seen some of those things. Again, it's in 112.7c, it says the entire system must be capable of containing oil so that a discharge from containment will not occur until cleanup occurs. In preamble and guidance, we say that should probably be about 72 hours. Diked areas around bulk storage tanks should be sufficiently impervious. We're not going to, again, take some sort of quantitative measure to see if it's impervious. But if we see this showing up, we're going to tell you it's not impermeable, right? It's as simple as that. But you have a choice, right? There's some flexibility depending on the size of the tank, the volume, or container. Again, the volume and the material itself, whether maybe it's asphalt, maybe it's lube oil, maybe it's gasoline or diesel with different viscosity. So you can do dikes, berms, retention ponds, spill diversion ponds. I was at a large terminal that lost a tank that shifted suddenly, an older tank, and it lost 55,000 barrels of crude oil. But they had a system of ditches and retention ponds, and it all got caught on site, was stopped from getting off site. If that's what they want to do for containment, that's perfectly fine. But again, it needs to be appropriate. Now, here's the thing that really confuses people, that's size containment versus general containment. The beginning of the rule in 112.7c, it says you've got to have containment for everything. And then further down in the rule, like in 112.8, it tells you you've got to have specific size containment. So that's where it says for bulk storage containers, you've got to have the size of the largest tank and freeboard in that general area. So for all bulk storage containers, and there's a definition of bulk storage containers, tanks, drums, totes, loading racks, also have to be contained. But bulk containers have to have specific size containment, and that's the volume of the single largest container in common containment plus freeboard. Everything else is what we call general containment. So, for instance, like piping outside of containment, transformers, oil field equipment, oil field operational, oil field manufacturing equipment, piping runs. Those do not have to have containment that's specifically sized. In other words, the rule doesn't say you have to have a specific size or volume for it. It doesn't say the volume of the highest rate of liquid going through that pipeline. We call that general containment. So general is just about everywhere else where the rule doesn't say it's got to be specifically sized. So what does that mean, right? General containment means you have to address the most likely discharge from that part of the facility. The most likely. You don't have to do the worst case discharge. So I was just at a recent Army base, and they had piping outside of containment running between tanks and fuel dispensing for aircraft. And so this piping is running through. It's not double walled. Most piping facilities are not double walled. There's no berm underneath it. That almost might be silly. I doubt engineers would want a berm going all the way underneath it. Maybe. But the SPCC plan called for the worst case discharge from that piping of 13,000 gallons, right? Given the rate, the volume, the size of the line. But they don't have to. It's the most likely spill scenario. So in our questions to them, we're like, what's the really, you're the ones here that operate this facility. What's the most likely given the pressure, rate, volume going through those lines? Well, it's gravity feed and the pressure is low. And well, okay, is it going to be at a joint? Is it going to be at a cam lock failure? Maybe at the hose of the aircraft? So really, what is it? So whatever you determine is the most likely spot, the most likely discharge from the facility, and the most likely volume, that's what you have to have containment for. So if you tell me, well, 13,000 gallons from this pipe that's the worst case discharge, but the most likely discharge is 100 gallons, really. That's from a leaking joint. That's our most likely discharge. Okay. Well, then if you say that the most likely discharge is 100 gallons, then all you have to provide containment for is 100 gallons. So you have some flexibility here. Again, this is for things other than bulk storage containers. The owner operator, as looked at by the PE, is you determine what is the most likely scenario, and therefore the most likely volume spilled. And whatever volume you figure out is going to be spilled in the most likely scenario. Sorry, I'm repeating myself a lot, but a lot of people get confused, and maybe it's just the way I verbalize things too. So Rajib, you're going to jump in and help me clarify things if I need to. Whatever you determine is the most likely spill scenario, and that volume is all you have to have containment for. So maybe the most likely spill scenario is 50 gallons, depending on where you're at. Maybe it's a tanker truck coming to offload some fuel from a small tank, or unload some fuel. And the most likely spill scenario from that transfer point is a cam locker hose failure. And by the time the driver can get to the system and shut everything down, giving the rate, the volume, the size of the hose, and the time, maybe it's 50 gallons. Well, if that's what you say, that's fine. If PE agrees to it, right, signs off on it. 50 gallons. Well, let's see, how could you do that? You could have containment around where that piping is going to be, or maybe a spill kit will work. And I'm going to get into that in a minute too. If the spill kit is rated for 50 gallons, and that's your most likely discharge, your most likely scenario, all you have to do is provide containment for that amount. If it's 50 gallons, then you have a choice of how you build containment for it. You could use a spill kit, you could use a berm, you could use a gutter, you have choices, right? So again, for bulk storage containers, again, that size containment, because the rule says it's sized. It's the volume of the largest single container with sufficient freeboard for precipitation. You've got lots of flexibility at earth and berm. You could have concrete walls. For earthen berms, as long as it'll hold the stuff, that's good. Again, we don't look at quantitative measures. Some people want grass on top of the berm. Some people don't want grass on top of the berm. If you got grass on top of the berm, we're going to say, can you inspect the berm and make sure that it's got good integrity? Many places do not allow vegetation on top of the berm so they can see through to the gravel or the soil, see if it's cracked open. If we see large rooted vegetation, we're going to say that's inappropriate. That happened up in Alaska recently on one of my inspections because there were trees growing out of the berm. And that the roots and animal holes can compromise the integrity of the berm, and we've had spills that go right through those holes. So you've got to be able to make sure the secondary containment has good integrity, right? No trees, please. For freeboard, again, for precipitation, we did not set a standard. So people are used to this and they say, well, it's 110% of the largest tank, 100% of the volume of the tank plus 10% for freeboard. There's no such number in the rule. It's not 110% if you believe that 110% is appropriate for that containment, given the location you're in and the design of the tank and where you're at. That's fine. It's signed off by the PE. But there's 110% is not written into the rule. Again, the proper method, good engineering practice. We say base it on your site-specific precipitation. If 110% works for you and works for the PE, fine. It may or may not be acceptable. That 110% we believe came from the American Petroleum Institute from years ago. That was sort of a rule of thumb for people. All right, let's move on. So I hope that that's clear. The guidance that we have in that inspector guidance, we suggest, and this is not enforceable, but we suggest it as a best management practice when the engineer is considering the freeboard calculations. What should you have? We suggest a 25-year, 24-hour storm event. It is good for looking at precipitation. It's not a requirement, but we would suggest that as a best management practice. Now, we've had incidents where a hurricane or a tropical storm came through and there was a whole lot of water, obviously, in containment, and things got out of hand. And, the SPCC rule is not meant for particular hurricanes, right? There's nothing in there in the rule that talks about hurricanes or large storms. Volume of the single largest tank plus precipitation, right? Again, up as signed off by the PE. Active measures, I mentioned this a minute ago. The rule after our amendments allows what we call active measures, meaning a person takes an action. Like, for instance, taking a mat built for a storm drain and putting it over the storm drain before you load or unload oil, right? From tanks or containers or trucks, right? It's really meant to be used for small volumes of oil and general secondary containment, right? It's not meant for large expected spills like those from a tanker truck. Can be very appropriate, right? I mentioned a spill kit. You see in this upper photo here, this is at a small airport in Oregon, and they've got a drain there. And from this particular area, they only expect 50 gallons. And so they're going to use an active measure and a spill kit. The key is this. If you're going to use an active measure, then it's got to be at a location that you can get to it easily. The spill kit ought to be rated for that volume of the spill that you're going to clean up. You've got to be able to deploy it in a timely manner, and you've got to be able to discover it in a timely manner. If it's in an unmanned facility like oil field production, like a lease or something like that, and the gauge or pumper doesn't get to it but every 2 days, that's not going to be appropriate. It's got to be looked at a regular schedule and be able to deploy it in a timely manner. So here's some examples. using a spill kit. I've already mentioned that a couple of times. A properly designed storm drain, closing a gate valve that controls drainage from an area prior to a discharge. So general containment, again, applies to non-bulk storage containers and transfer areas. Bulk storage containers defined in the rule. There's no specific size volume requirement. I mentioned that a little while ago. You look at the most likely spill scenario, you determine the volume for it, you provide containment for that volume. And then you got to write this in the plan, right? You should be detailed in the plan. Our most likely spill scenario for this piping area is blah. Here's containment for it. So oil field equipment, transformers, mobile refuelers, transfer areas, we mentioned that earlier. I've gone through this probably ad nauseum now, right? But you can always ask another question. You should consider typical failure mode. What's the most likely quantity of oil? You've got to be able to have the ability to detect and react to the discharge in a timely manner. So I'm going to move on. I'm taking a lot of time here. General containment. So for transfer areas, some people are not aware that like a card lock at a facility like this gas station in the upper left-hand corner, right? Card lock where for commercial entities, typically they come to fuel up and they have a card like you might use at Costco or one of those other places like that. This place is regulated not because of USDs, but of the ASDs that are in the background. They meet the threshold quantities. They're above 1,320 gallons total capacity. Not what's in the tank, but total capacity at the facility. There's the storm drains there that get to a creek, you get to a waterway. So they're covered, which means any transfer area is covered because we regulate the facility. All those pumps, that's all transfer areas, right? Where you transfer to a car or a truck, that's general containment. You've got to have some sort of general containment for a transfer area. General containment. Oh, okay. Well, what's the most likely spill scenario and volume? Oh, well, the most likely spill scenario and volume here is we walk away or, from the pump and maybe it's 10 gallons. And that's all they have to have for containment. If you'll notice, there's a slot drain around here in sumps that could contain 10 gallons. That works fine. That's great for containment. This lower photo on the left, you see that it's another transfer area, loading, offloading area, not a rack, but a loading, unloading area for trucks. And so that so the two parts of the rule that deal with that, or two parts of the rule that certainly deal with that, and that's containment and also drainage, right? So there's drainage from undiked areas, which that is. It's open to a ditch there. And it also has to have general containment, which is really what we're talking about in this photo. A general containment, what's the most likely spill scenario? What's the most likely volume when you're pumping in or out of that tank? Provide containment for it. I'm not sure what it is there. The two photos on the right, same thing. It's piping run, given the rate, volume, diameter of the line, pressure. What is the most likely spill scenario going to or from this facility, right? And you have to provide containment for it. Maybe you've got a system of drains, of ditches around there that will not go off site. Maybe it's a small amount and it'll absorb into the soil and you get a spill kit after it. I don't know. Lower photo again, that's a transfer area where that pump is. A lot of folks do not recognize that or know that we would consider that. So that's a transfer area that has to have secondary containment. It's general secondary containment. A loading rack. So this is a specific site in the rule. If you have a loading rack, and it's like in this upper photo, most everybody would recognize what a loading rack is with loading arms and unloading arms. That has a specific requirement for loading, and that's the volume of the single largest compartment of the tank, truck, or trailer, right? So they're typically divided up, the trailers are, or the trucks, tank on the truck. And so if it's 2,500 gallons for the largest compartment of the tanker trucks rolling in there for the loading rack, then you have to have containment for that. But most other areas are not a rack. They're loading, unloading area, just like This photo here on the lower left, right, they load in and out of that tank. That's not a rack, it's a loading area. It's general secondary containment. Same for this lower photo here where these tanker trucks are. They've got a single load line going into the truck, and it's not a rack defined regulatorily. So again, the owner operator decides what's the most likely spill volume and provides containment for it. Let's move on to drainage, right? So we've got two areas really to consider. One is drainage from diked areas around the tanks or drums, right? If you have dikes, then you have to restrain when you drain from there. Typically, the valves got to be closed. You need to check for oil, remove the oil first, and then drain under responsible supervision, and then close the valve and make sure it's secured. The valve should be open, the valve should be manual and open and closed, right? We don't want to see an open valve inside secondary containment or at a dike or berm. We've had spills where it went straight out that open valve, right out to a waterway. So that's dike storage areas. Again, you check it for sheen, remove the oil, and then you can drain it out. If you drain it directly out, you can drain it out. You could also drain it to a wastewater treatment plant on site. That's perfectly fine. For the next area is drainage from undiked areas where there's oil, right? So in oily areas, like again, piping runs, like we've seen today, for facilities like that, loading, unloading areas, you still have to not only have some sort of containment, but you have to consider drainage from undiked areas. The rule talks about drainage from diked areas and from undiked areas. And so at the end of the day, if you have an oil spill, it's got to be able to be caught. If there's any drips or leaks or whatever, it's got to be able to be retained on site. So the rule says you can go to ponds, lagoons, catchment basins, maybe sumps, maybe it's a small amount, maybe undiked areas, general secondary containment. Maybe you're only going to lose like 10 gallons. So maybe you got a catchment basin that things flow to. It's designed that way and it'll catch it. That'll work. Here's a couple of photos. These are photos in the Pacific Northwest. I inspect a lot of hydroelectric dams, and these tanks could exist anywhere though. And so they've got on both these, well, the left photo is double-walled tank. That's great. So it has secondary containment for the tank. But what people were not thinking about was, well, a tanker truck comes up here occasionally and loads into that tank. Well, what about secondary containment for the transfer area? What about drainage for the transfer area? Drainage is undiked. And you have to have general secondary containment for that transfer point, right? Same for this tank on the upper right. This is on the upper deck of a dam and right over the, I think this is the Snake River maybe. And so the truck will come. That's certainly a transfer point. There has to be general secondary containment and drainage thought of. Well, there's expansion joints in this concrete deck. And if they spill something, it's going to go straight down through the expansion joint into the river. So things to consider. Something else to consider, the pipe on that right tank going in and out of, well, that's in an undiked area. How are you going to contain the spill from that? What's the most likely spill scenario? What's the volume? You have to have containment for it. So I'm going to go on. We'll find some common inspections, pitfalls, things we've seen over time. One thing is certainly a poorly written plan, or the PE or the plan writer has little experience with the regulations. They don't understand them. They don't understand the amended regulations. We get sometimes very generic plans. And again, I talked about site specific. Please make it a site specific plan. It's good to have regurgitation of some of the rule language. Some places will do that, or some writers will. They'll put a paragraph over, they have the rule language, and then below that, they write in specific language. This is how we do it here. The writer is not taking into account specific detail. I just mentioned that. And the other thing is we often see a poor understanding or demonstration of tank integrity requirements. What I found recently is when there is a cross-reference, it's general. There's not enough site-specific citations there. And the thing that I like to see is if you have something like that's not applicable, please say so, or put it either in a heading or the table of contents. For instance, if you have shop-built tanks and you follow SP001, there may not be a need to do, there isn't a need to do brittle fracture analysis. The rule talks about a brittle fracture analysis for field-erected tanks whenever there's a change or repair. Well, if it's not applicable to your facility, it's helpful for an outside reviewer and for your own people, because again, you're going to be training your oil handling personnel to say either in the cross-reference or table of contents, 112.7 blah, and write not applicable at this facility. I like to see that personally, or maybe you've got a header inside a chapter or section inside the plan that says brittle fracture analysis. But it's really great for me or for an outside reviewer to go, it's not applicable here because all these tanks are shop built, right? I think that's very helpful for us as outside reviewers. When you write the plan and it's your facility and you're there at the facility all day in and out and you see it and there's some writing may be very clear to you because you know in your head stuff that's not really specified in writing. You already know, everyone's familiar with it. Oh, that's good. But for an outside regulator or someone like me or maybe an auditor that comes along, I don't know that facility. And so sometimes little things like that are very helpful, right? Because then I'm searching through the plan, trying to find out, is this applicable or not? And what we often find is there'll be little pieces of writing in the plan that deal with, like, say, drainage, right? They may address drainage in different chapters in the plan. So now I'm looking back and forth through the plan and trying to find out where all the drainage sections are. And if something's not applicable, that just makes it a little easier. We often find facility diagrams are incomplete. Let's see, I was going to go through that a little bit more, but you got to have the containers, the piping, and transfer stations, right? Transfer areas, again, like what we just talked about, those transfer areas. Piping is a thing all of its own. A lot of facilities are like, well, I'm a refinery and I can't show every single little pipe, right? Not on your plan. What we're looking for is sort of a process flow diagram, the main piping to and from, right, where it's going to. You don't have to show every single little pipe. Tank integrity schedule, we will ask for that so we can evaluate whether you're implementing your plan or not. And it's nice to see those in the plan. They don't have to be in the plan, but it's best laid out in the table. List your tanks. Here's the standard. Here is the date of the last external API 653 inspection. Here's the date of the internal, external, when the dates are due. Same for SP001. That's very helpful to see. Another problem we have is the failure prediction in the rule. And I mentioned this earlier, for general secondary containment, a lot of times people use the worst case discharge for containers when they don't need it. If the corporation and the owner and the company decide that's corporate practice and you want to do that, that's fine. If they say we want to consider the worst case discharge of 13,000 gallons from that piping that goes to the aircraft transfer area, fine. But you don't have to. Make it easy on yourself. Again, I'm not a PE. We do have some PEs on staff, but we can't be your PE and write it for you, right? We can offer up suggestions, best management practices. And if you choose that you want to use worst case discharge, well, that's fine. So let's see, for this failure prediction. So the rule says you should be looking at the most likely scenarios. What's going to spill? What's the rate and volume of the oil getting out, and where's it going to go? So the rule requirement is what's the type of failure, given your experience at your facility. Oh, it's a cam lock failure on this hose, on this hosing, and the rate of discharge is going to be 10 10 gallons an hour. All right. So what's the total and where is it going? So there's some homework to do. We talked about general containment. I probably made everyone go to sleep talking about that. But again, it's often misunderstood. I want to make sure we can clear that up as much as possible. Um, so we often have a poor description or no description of what is the most likely spill scenario in the volume. That should be written in the plan, and often we don't see that. Um, Now, if you're claiming impracticability for secondary containment for bulk storage, um, for some reason you can't have secondary containment, um, you can make an impracticability claim. If you do that, then you have to have a contingency plan. And the rule says the contingency plan should follow 40 CFR 109. Now, if you go look at 40 CFR 109, it'll say contingency plan. I don't have the rule in front of me, but for like states, cities, counties, local governments. Well, and you're like, wait a minute, I'm not one of those. I'm private, or commercial. It doesn't matter. You got to follow that, the format of 40 CFR 109. So we often find just a general contingency plan and not site-specific stuff for that place, that waterway, the staff working it, the emergency responders, the call-down list. So we need, again, some site specificity. And I think finally, one of the other things that we see, I've just seen it recently, is the plan is written to older versions of the regulations and not taking into account the amendments. Now, the amendments started in 2002 up through 2009 or so, and everything was finally due in 2011. And it got confusing. I'll give everybody that. Politics intervened, unfortunately, and we had several different versions. And we also tried to give some flexibility in places where we thought that we should. For instance, technically under the rule before 2002, if you had a big Caterpillar or Case or heavy equipment dealership, and you had a bunch of bulldozers with tanks over 55 gallons and you're near a creek, we could have said, oh, well, that needs to be in the SPCC plan, but we didn't feel like the SPCC rules were really meant for large dealerships of heavy equipment, right? Similarly, for Walmarts or large warehouses, maybe where they've got over 1,320 gallons. Maybe they got thousands and thousands of gallons of oil, but they're in quarts and gallons and 30-gallon totes. And so we're like, this rule we didn't really think was meant for those type of facilities or large package box stores, right? And so that we changed the rule during some of that time to try to give more flexibility. That also added a little bit more complexity, but to give some more flexibility if we could. All right, diagram requirements, location and contents of fixed oil containers, storage areas of mobile or portable containers like drums, location of exempt underground storage tanks, connecting piping and transfer stations. That's all you have to have. What's nice to have is the stuff in this right-hand column. And we often see that. What's the direction of flow if you have a spill or rainwater precipitation? Where is it going? That lets us know where the oil is going to go if there's a spill. What I often find, and it's probably OCD on my part, is there's not a legend. And so it's hard for me to sort of figure out what are these different things that you're showing? What are these symbols? What does that mean? Where's stuff going? That would be really nice to see a good legend, not required in real language, compass direction, location of valves, topographical information. Don't have to put it there, but if you can, it's really going to help the reviewer. And if you're training your own folks, or you got new employees, that might be good for them too, right? You're supposed to train on this SPCC plan. Here's an example that we use that is good. It shows the bulk storage containers. Everything's listed. There's a symbol legend on the left. It shows these arrows, concrete surface, truck parking, asphalt. It shows flow, where a fluid is going. It shows containment. It shows a fence line, railroad. It gives us a good sense in if you have an oil spill, what are the things? So you have to show tanks, right? Containers, what's in them. You can refer off to another table, I think, if you need to. It's nice to see it on the diagram. But again, if you're ExxonMobil, Baton Rouge, or Beaumont with 1,100 tanks, you're not going to put that on one diagram, right? Um, it shows some piping to and from loading areas to and from the tanks. That's good. Here's the card lock transfer for fueling, oil water separator. So this is a nice facility diagram. All you have to have, again, are these items on the left: location and contents of fixed oil containers, tanks, drums, mobile storage area for mobile or portable containers, exempt USTs, connecting piping, and any transfer areas. Failure analysis. We mentioned this a little while ago. Again, you do a failure analysis. Often it's done in a table where experience indicates reasonable potential for equipment failure. Maybe not everything. Where does reasonable experience at your facility show you might have equipment failure? What, tank overloading or unloading equipment, right? Overflow, things that are known to be a source or potential source of discharge. And in this table, or you could do it in verbiage or language in the plan, what you have to predict: where's it going, what's the rate of flow, and what the total should be, right? It's that simple. It may take some time if you've got a lot of equipment. Here's an example table. We've got this on our website. You could use something like that if you like. Here it is filled in, right? Where does reasonable experience show it's going to go? We've got the tanks, what are the type of failure in this column? Well, tank overfill leaking, what's the rate? Well, the engineer said, golly, it could be anywhere from 10 to 2,500 or 10 to 500 gallons. Where is it going, right? And what's the total that it could be caught? Here's piping down here, above ground piping between diesel and gasoline tanks and the dispensers. Their most common discharge scenario, fitting, leak, or failure, 1 gallon. All right, well, it's just going to go out in a radial fashion above the ground. There's double wall buried piping, and there's double wall secondary containment. That's where it's going. So again, failure analysis, right? Here's some planned pitfalls. We haven't discussed oil water separators much, but if you're going to use oil water separator for secondary containment, then you really need to discuss the capacity and rate and volume of that oil water separator. How much oil can it really contain, right? Just like you would secondary containment. We've already talked about spill kits and their absorbent removal capacity. That ought to be discussed. Impracticability, we mentioned that a minute ago. When you make that claim, you should really describe in the plan why it's impracticable. And then you got to have that contingency plan following 40 CFR 109. And what we often find is, again, a general writing and not site-specific writing on 40 CFR 109. But you really ought to lay out what are the duties of our persons responding, what's the notification procedures, etc. Well-defined and specific actions to be taken after discovery and notification. And then things like, how do you facilitate recovery of damages and enforcement measures? I was entertained by one of the hydroelectric dams because their contingency plan said, as far as notifications, they're going to call the NRC and not the National Response Center. Their contingency plan was for calling the contracting company that comes and does removals, NRC, National Response Corporation, which has been bought and now has different names. But again, specificity, it's been a common theme that we've talked about today, but 40 CFR 109 is what you need to follow. I mentioned this already. I'm going to move on. You must have a written commitment of manpower material signed, right? Equipment, materials to expeditiously control or remove a spill, right? On our website, we have a national website. Rajib mentioned this earlier about our guidance for regional inspectors, and it was updated in 2013. It's meant to be dynamic and updated again. The website link is here. That website and the main website that it's on goes through, there's a lot of presentations and information and helpful information to help you with being compliant, understanding the rules. We put that guidance together to help the public, but also for transparency on what we're really looking for industry, right? Here's what we're really expecting, and of course, for our own inspectors. It helps us try to be more consistent. We're not always as consistent as we would like to be, but this lays it all out. Here we go again. It's released in 2005, updated. It addresses most aspects of the rule. Again, intended to establish a consistent understanding amongst our own inspectors as well as industry. And that's it for now. We have some other slides. If need be, we can go through on that EPA website. If you go through it, you find guidance and references. You'll find a map listing each EPA region. There's a list of the oil, SPCC, and facility response plan contacts. I'm one of them for Region 10. We have a person in each state, or you can just always call me, or you can look it up for the state that your facilities are in, that you're writing plans for or operating in. We also have a 1-800 number. It's called the Superfund TRI, EPCRA, RMP, and Oil Information Center. Contractors are manning that line during the day. They might be able to help as well. So, Rajib, I think that's it. I stumbled around a little bit. If I've gone south, hopefully you'll jump in and correct me or have some questions, maybe.
Thank you very much, Richard. That was absolutely a fascinating presentation. For those of us that have written many SPCC plans, and always wondered whether how good they are, because as I mentioned before, they're not reviewed and they're not really, till you have to implement them, you don't really understand how good they are. We actually have come up to the end of what we had for an hour, but we do have a couple of questions in here that if people can hang around for a little bit, and if you can hang around for a little bit, I wouldn't mind getting a response to. And one of the questions that came up here is on the technical impracticability for secondary containment. Facilities, you have seen facilities where this exemption claim's been made. We've made it on behalf of certain facilities where it's difficult to have that secondary containment. But when you do evaluate the claim and you look at a plan, how thorough what are your thoughts on adequate documentation as to exactly how thorough that should be, and the follow-up contingency plan with that?
That's a great question. I don't. I'd have to go back and look. I don't think we've got much verbiage in the rule about what is the sort of documentation, right? So we're going to probably look for a statement that just explains it well. Maybe there's safety concerns. I know for the hydroelectric dam, sometimes things go into a big sump and pumps turn on for that sump regularly and flush everything out to the river, and they can't shut those pumps down or they'll flood the dam. And so great question. I can look that up, Rajib, and try to get back with you. I think certainly it ought to be discussed in their plan. There ought to be a section on it or a paragraph or two for or whatever you need for that facility that lays out the main components of why you feel it's impracticable. In some places, some engineers will cite safety. In some places, typically for tanks, it's rare that we really find it to be impracticable, right? But maybe there's not enough room. Maybe you built your facility and the highway people came, and there's a railroad and a highway between the tanks caught between, and there's not physically enough room. Things like that, right? It's not that often for bulk storage containers that we find something truly impracticable. I don't know, other than a really good explanation, and that's not very helpful answer to you. But I'll try to see if I can find any guidance on that, and then get that back to you.
That'd be great, Richard. One other question that came in is about the STI and as API inspections. And APIs is generally within 5 years apart, but STIs can be as long as 20 years in between
That's right.
inspections and the requirements. Can a facility do its own tank inspections in between the formal API and STI inspections?
Yes, you can. And they ought to be trained. I mean, they ought to be trained by the facility, but your own employees can do, your monthly and annual inspections. For the formal ones, it's got to be a trained STI and certified STI inspector. Yes.
Very good. Another question that came in, and this relates to some slides that I made you take out, which is to talk about when DOT versus EPA regulations kick in for rail cars, tankers, and semis at facilities. Now I'll clarify the question if people don't quite understand. There's an MOU between DOT and EPA that says, where DOT has jurisdiction, EPA does not, and vice versa. How do you evaluate that, Richard?
Oh, whether it's transportation related or non-transportation related? Yes.
Right.
Okay. Well, that's a good question. As far as jurisdiction, that's one of the first basic things we always look at. And so oftentimes non-transportation related means it's fixed facility. But in that MOU defines what's transportation related and what is non-transportation related. And so we will go back and look at those definitions. We also have some guidance, for instance, on pipeline terminals that for years has said, well, we're all transportation related, and so you don't have any jurisdiction. And we would take a look at it and go, oh, no, you're not transportation related. And so we had an agreement and we had a meeting. In fact, I was there personally with the Undersecretary of the Department of Transportation several years ago. And what we looked at is for tanks, let's talk about tanks, and I'll try to get through this as well as I can, fast as I can. If it's purely a pipeline, what we would call pipeline in and pipeline out, right? So transportation of oil into and out of via pipeline and no other non-pipeline mode of transportation. In other words, you're not hooking up a vessel to it, ship, tanker. You're not hooking up a rail car or truck. It's just in and out by pipeline. Those are what we would call a breakout tank or a DOT facility. That is transportation related. We're not going to exert jurisdiction there. For other facilities, like a port facility that might be bringing in intermodal tanks or trucks, right, that are moving from vessels or rail cars in a rail yard. They're moving through. They're coming from one place. They're going to another. And the manifest and paperwork says it has not gotten to its final destination yet. So if it's still in transportation, like in a rail yard, coming through, it gets the tanker cars gets stopped there for a week or a few days or a few hours, whatever it is. It's really not storage for purposes of that rail yard. It's still moving in transportation. Once it gets to its final destination, and that's what the paperwork says, that's when we exert jurisdiction. So if it's moving through, a great example is ports. When I was younger, I might say, well, they've got thousands and thousands of gallons of oil sitting there in intermodal tanks or other tanks. If those tanks are still in transportation, I can think of, for instance, in Alaska, Louisiana, Texas, where intermodal or mobile tanks or drums are moving through to go out to an offshore oil rig or platform. That's the final destination. Is if it's sitting in the port or at that dock area, but it's moving through, it's not got to its final destination, then we would not exert jurisdiction at those facilities. For rail cars coming into a terminal to offload, if they're starting to sit there for a long time, and this will be up to the region and up to the inspector, coming through to unload denatured ethanol at a refueling, distribution, bulk storage terminal, refined product terminal. And they typically bring in denatured ethanol to add as an additive at the truck rack. If that rail car is sitting there and the function really is to offload it, and it's there for a day or two, we would say, well, it's still what am I trying to say? If it's there for a long time, and such a long time that it seems to us like it is supplementing storage, that facility is really using that rail car for storage until they can get it off. It's there for a week. Then we might call it a storage container, and then we would exert jurisdiction. Otherwise, if it's just moving through, like again at a rail yard, we would not exert jurisdiction. I don't know. Does that help? I hope some.
Oh yeah, totally does. This is open to everyone, folks. If you have a question, please raise your hand and put it in the chat. Or actually, I'm not sure if Amy can unmute you or not. I'm gonna we'll keep this on for another few minutes and close at 4:15. The one other question that came up is that if you have a spill from a general container that exceeds the most likely spill volume, do you then go back and update your secondary containment measures or improve those for the future? Do you look for that? Do you see that coming into play?
Oh, I think that's a great question, and something as a follow-on. People might say, well, what about enforcement, Richard? Y'all are going to enforce. You said in your plan the most likely spill was 10, and it turned out to be 100 gallons. Are you going to enforce on us? And I'd say, not if it was really sometimes those things happen. The rule clearly says most likely spill. So we shouldn't be enforcing on that. If it got to a waterway, that's going to be the key thing here. So if you have a spill and your most likely spill volume, what you said in the plan, but it got to a waterway, then we're going to take another look at it. And we can require an amendment to the plan where you do need to update the measures. And we might even could require where you put specific size containment around it. That's rare, Rajib. I've almost never seen that.
Mm-hmm.
But how are secondary containment measures updated or improved for the future? I would leave that up to the owner operator. Maybe take another look at it. Normally, if it's just get to soil, you don't have to notify us. You might have to notify the state because sometimes there's state recommendations, right, on a certain volume spill to soil or to the ground. But I would take another look at it, maybe visit with your PE and say, well, is this really the most likely spill and it was just a one-off thing? Or, how do we do that? If it threatened to get to a waterway or actually got to a waterway, that's when I would take it more, I would really, truly reevaluate it and certainly update it to a higher number just to make sure that doesn't happen again. Once it gets to a waterway, it's a pain for the facility to clean up. It's expensive. And then you're going to have potentially EPA involved and the state, or maybe the city or county, and you're going to have everyone on your back, right? And so it's the whole ounce of prevention, right, kind of thing. I don't know what to tell you beyond that. I think the waterway threat is a key thing here, and maybe it's just a one-off deal. That's up to the owner operator to take a look at, as well as I would enjoin your PE to take a look at it too.
Excellent. Well, Richard, I don't have any more questions coming through right now, so I'll say thank you very much for this absolutely amazing presentation that you put forward. Love it. I love this picture too, and I want to know if that's on Airbnb or something like that. I can
That's, I believe that's in Southeast Texas, and we used to joke that was my family's home, but it's not my family's home. It's a great photo. Well, thank you. It was a great opportunity for us as well. And I'm hoping that it helps people understand the rule better. And as a follow on, Rajib, if you have more questions, you can always get back with me. I'm sure you will. And then I will look for the answer. I've already got that one note to get back to you on. And evaluating, I guess, impracticability. I think that was the question. How would we document that? So thank you so much. I appreciate it. Sorry I stumbled through a little bit, but if it helps everybody understand better, then that's our goal.
It was awesome. Amy, can I ask you to come on real quick and wrap this up and tell folks where the recording is going to be?
Absolutely. Thanks everybody for joining us today. We'll send a copy or a link to the recorded version of today's webinar via email to all of the participants today. So expect that over the next couple days. And just wanted to say thank you to Richard. Appreciate all the valuable information and thank you for sharing your expertise with us. And with that, Rajib.
One last thank you to Joe McElroy. He's in our Soldotna office. He was the one that was instrumental in connecting Richard to me and making this whole event possible. Once again, thank you, Richard. Thank you, Amy, for
You're welcome. Thank
amazingly
you.
hosting through all this and making it all so smooth. Take care, everyone. And that's it.
Have a good day.
Bye-bye.